Hi, my name is Aman and I am from Team Clear Route AI. So, the problem statement that we're trying to solve is civic issues. Now, India is a developing country and we as honest citizens are a part of this developing country. So, obviously, if there are complaints like broken footpaths or open drainages or some potholes, it is our duty as citizens to actually get our voices heard. And it is the government's duty to actually ensure that these problems are properly prioritized, assigned and resolved. So we have created an entire system just to solve this problem. So this video is going to be divided into two parts where we explain our end-to-end solution. So the first part we are going to explain how the fully functional system works, and the second part we can explain how the backend works. So now Arya Kumar can explain to you how it works and looks on the citizen side.
Hi, I'm Arya Kumar Mishra, and let's say I'm a citizen just walking down the road, and while walking I see a pile of garbage. So what I will do is I will open this app. I'll set up a password, a simple password which I will confirm, and I will sign up. Once I am signed in, I'll come onto this login page where our AI model detects our location automatically and suggests the most reported issues in that area. Since we do not see our garbage issue here, we'll click on this plus icon and we'll click this street not swept or littered option. We'll enter a title. We'll enter a small description for this. We'll click an image. We'll click OK. So our model automatically detects our location, latitude, and now it verifies through AI whether we have put in correct image for the category or not. We can view details and we can see all the images. We can also go on to Google Maps to see that our location has been correctly identified. So now we can go back here. We can also see the reports, and here we will see all the complaints that we have posted. We can also go to our profile, and we on the updates page we will get the notification as soon as any government official takes any action. We also have this chatbot for people who are not known with this app, so they can come here, they can easily go on to FAQs, they can ask how this app works, they can go back to main menu. If they want to report a new issue, they'll be guided and they can directly go on to the page. They can again put in the details and register a new complaint. Now Rashmi will demonstrate how this will look on the department admin's page.
Hi, I am Rashmi and I'll be acting as the sanitation and solid waste department admin, and I'll show you how the interface works. Okay, so starting in with the login, we'll log in with the sanitation and solid waste department credentials. Now I sign in and it will take us to a high-level dashboard where we see real-time updates of total complaints and how many complaints have been posted, how many have been opened, and how many are in progress and resolved. Now basically the performance insights here are resolution rate, average response time, active departments. Moving forward, we can also see the latest activity posted by someone. Now moving forward to complaints to see it in detail, the complaints in detail. We go here. As you can see, ID, date and time, category, department, these are all our these are what we fetch. And now as you can see, we are also using duplicate detection, which basically means we are using geospatial data to analyze if people are posting similar complaints from the same location, then we take it as that it is a high priority issue. Now we'll be opening the complaint posted by Arya Kumar. We can also download it and view it. As you can see, we can also fetch the location of the complaint too. All our complaints have been integrated with a map. Also go to open to see how many complaints have been opened. Our location is Vadala. So we posted the complaint from Vadala, and you can see all our details are visible here. We can put in the details, and then help and support is also available. We also have a dark mode dashboard so that it's easy on the eyes of the users. We have also added the notification feature so that we can get the latest updates. As you can see, the dark mode dashboard through the complaint section. So now I'll be assigning it to Neeraj. And as you can see, the status has been changed to assigned. Now I'll pass it on to Neeraj.
Hi, I'm Neeraj. I'll be acting as an employee who is actually going to visit the site and do the work and then upload a resolution proof. So here you go. So let's log in as a worker 4. So here you go, we are logged in successfully. So we can see the assigned complaints at the top. So we also have filters for assigned, in progress and resolved complaints. So we can now see the assigned complaint at the top that was just registered a while ago. So let's say we open the complaint. Now we can see the details of the complaint right here, and the image. We can see open in Google Maps option to confirm whether we are on a correct location or not. It seems we are on correct location. So let's get back to the app. Let's start the work. This option just patches the status of the complaint to the in progress. So now we go to in progress. Now let's suppose the work has been done, the cleaning has been done. Now we want to update the resolution. Now we can write some short description about it. And we take photo of the clean street. Okay, and we submit the resolution. So by the time the image gets submitted, the image has been verified by AI using our progress detection AI. So actually it assigns the quality of work in the complaint section. So you can see the complaint has been resolved. You can see the resolution image and the complaint image as well. So here is the summary section of the employee side. You can see how many total assigned complaints were, and the assigned complaints and resolved complaints. You can see the updates, but there are no updates as of now. And you can see the profile of the worker. So the department of the worker is sanitation and solid waste department. So Arya will explain how will it look like on the super admin side.
Hi, I am Arya, and let's say I am the super admin, and I am going to show you how the super admin works. Now let's log in to the super admin. This is the super admin dashboard. As you can see, the dashboard is similar to the department. So we can see the total complaints, open issues, in progress and resolved of all the departments in one single widget. And we have also added complaints by department. We can see 4 departments: sanitation and solid waste, roads and drainage, electricity and water sewage. We also added category distribution, and we can see broken street light has faced issues by most of the people. This is the quick actions, and this is the recent active summary. This is the complaints page. We can see all the complaints of all the departments in one single page. Here we can see the resolved one. We can see resolution information, resolution description, and also the complaint images. As you can see, Arya Kumar uploaded a complaint, and also you can see the resolution images above the complaint image. You can also see basic information like date, location and description as well. This is the map view. We have added status like open, assigned, in progress, resolved and reopened. We can see all the complaints of all the departments in one single map view. Let's open a complaint that was just uploaded on the map by Arya Kumar. We can see the latest complaint on the map view as well. This is the reports page we have added for the super admin. We can see complaints by category. Broken street light has many complaints faced by the users, garbage piles, road damage and sewerage issues as well. We can also see complaints by department. We can see status distribution like how many complaints are open, resolved, assigned, reopened and in progress. We can also see the department efficiency, for which department has higher resolution rate. We can also see performance trend, and we can see the overview of all the complaints. In the department page, we can see all the 4 departments that are working. We have also added their status as active. Now, Aman will explain the AI implementation and how the backend system works.
Hi, so Aman here again, and I'll be explaining how the AI implementation works and how the entire backend system works. So I'm going to be demonstrating how all of the database works, how the backend code works, and how the AI implementation works. So now let's start off with the AI implementation first of all the AI models we've done. Okay, so first we unzip the dataset, and we divide it into training, testing, and validation folders. For all of these different categories, we have different categories like damaged roads, broken street lights, damaged infrastructure, hazardous wiring, water leakage, all of that. So then what we do is we seed it. We perform data augmentation to actually ensure that our model is robust and reliable across all different capacities. Then we have around 7,820 actual raw images across 8 different classes, and then we actually augment it and it becomes 15,200, and these are what the augmented images look like. Then we actually sample the class, and then we perform the entropy loss function with an Adam optimizer function to ensure that there is minimum loss, and it finds the gradient descent optimally. Then what we do is that we actually train it on 20 epochs, because that's where we found the best accuracy. And as you can see, the loss gradually decreases, and we achieve an accuracy of 93% on the testing data. But I can show you this here. So as you can see, for it predicted it as a test broken street light, and actually it was broken street light. So these are the validation data sets. And if you want to see how it looks like on unseen data, these are all images, 134 images that we have sourced that are not included in the training data set at all, or the validation data set. So these are completely new images. And out of the 134 images, approximately 110 images have been classified completely correctly, and it has an accuracy of around 85 to 87%. And this is what it looks like. We can fine tune this further for sure. And now I will show you how the garbage progress detection model works. So we have created progress detection model for each of the problem categories, and this is what it looks like. First, we install all of the requirements, then we seed the data, we extract the data into the correct folders, and then we put it into the correct folders for training and validation. Once that is done, we are actually performing dataset augmentation to again ensure that the data set is completely representative of real world scenarios, and make sure our model is actually reliable and robust. The batch size of 32 to ensure the ability to actually train on smaller GPUs. We are using resident model since it already has been trained upon 1,000 different layers, and the last layer is actually unfreezed, and we actually attach our dataset to ensure custom training. We are using again the same Adam optimizer function, and using early dropout to prevent any overfitting. So then we come down and we have trained it upon 35 epochs, because that is where we found the best accuracy and the lowest loss function, along with no overfitting. Then we write the code to actually check all of the console logs and actually be able to see how the training has been carried out. So as you can see, it has had early dropout because it reached the optimal accuracy to prevent overfitting. And as you can see over here, we have written all of the functions to actually detect the progress. So we have uploaded two images. One is full of garbage, the other is not. First, we use cosine similarity index to actually calculate whether the two images are of the same place. So once that is done, we use SSIM global index to again confirm and verify that indeed these two are of the same place, along with the verification using the geospatial data, and we're also using delta probability. So what this means is that there is a 72% drop in confidence in terms of garbage. So this was considered as 100% confident that there is garbage over here, and now there is a loss of almost 100 minus 72, that is 28% sure that there is garbage over here. So there is a loss in confidence of it being garbage by over 72%. Then we check parameters like edge fraction, darkness, and local MAD for actually checking the lighting, and just to make sure the model is robust. And orb similarity ensures that truly, once again, it does belong to the same image. So now it has been given as a result. Then what we do, again, same two images to compare the progress, and this also has been resolved. Another comparison, this shows before and after. As you can see that there is very less change, so we say that this is actually unresolved. Yeah, so we have done all of this work for our progress detection model. This is the database that we're using, that is Superbase, which is hosted on AWS, and it is extremely scalable and reliable. And as you can see over here, the complaint that Arya Kumar had uploaded as a citizen, and which was resolved by Neeraj as the department employee, is correctly stored over here, which is worker 4, which is Neeraj's email that he had logged in with. The location is stored, the address, the description, the department ID, the category ID. The department ID is sanitation and solid waste, and the category is garbage piles. And if you want to see what it looks like in terms of the image, so as you know, the image is already stored in AWS, so that's why it is showing up with a URL like this that you can download as well. The department categories are here, the departments are here. This is what the schema looks like with all the social features and everything included. And we are actually using row level security to protect our database against any unauthorized access. And also in our backend systems where we are using fast API for asynchronous usage, which is actually fast API is extremely fast, reliable. It has amazing logging as well, and it is extremely robust for such heavy backend systems. And we have protected endpoints as well to prevent any unauthorized access. And apart from that, in the front end, we are actually using React TypeScript. So we're using TypeScript because it is extremely modular, it is extremely reliable, it works very well. It has a good server side and the client side caching, whichever suits our requirements the best. And the code base is built in such a modular manner that we can actually remove or add any components as required. And we are actually looking forward to more integration with AI. Things like detection of whether an uploaded complaint actually belongs to the government property or if it's a private property, having context along with the result model for progress detection. So progress detection is actually more reliable, and also looking deeper into things like better accountability for each department. So we have been trying to work to make a fully functional system. So we're hoping to get selected as we do. We would love to learn even more. We would love to implement things properly, and we're hoping to get selected. Thank you so much for listening to such a long video. I really appreciate it. I hope you guys like the presentation. Thank you so much for your time.